Hello, welcome to Designs for the Edge with Microchip Technology. Designs for the Edge is our new live stream program in which we talk about cutting edge markets and the technology that is transforming them. I'm your host, Eric Glatfelter. Joining me today is Alexis Alcott. Alexis, welcome.
Thanks for having me.
This is our first episode, as I said. Today we're going to be talking about technology that transforms sustainability. Before we jump into that, Alexis, would you give a little background about yourself for our viewers? What do you do here at Microchip? How long have you been here?
Sure. I have been with Microchip about 18 years. In my day job, I work as the lead for our marketing team for DSPIC digital signal controllers. And I also help with the corporate sustainability megatrend initiative, and it's with that hat on that I'm here for today.
Excellent, great. Well, thanks for being with us on our first episode. Excited to kick off the series. So let's talk about that word sustainability. It means a lot of different things in a lot of different contexts. Mm-hmm. When we talk about sustainability as a market, what does that mean to us?
Sustainability as a market is a really broad category, and so it encompasses a whole lot of applications, but the one thing they have in common is it's anything that's going to conserve resources, whether it's energy or air or water. Okay.
Now, lots of companies, Microchip included, talk about their sustainability initiatives, so help us differentiate between the two.
Sure. So Microchip has an ESG team that really focuses on our sustainability impact as Microchip and the things that we can control in our operations.
Right.
And then in addition, we see the sustainability application space as an area that has a lot of growth potential. And so we're trying to create the products, tools, and solutions that help enable our clients to build applications in those spaces.
Right. Okay. So if we think about like a factory, our sustainability is using fewer resources, using less water and chemicals in manufacturing semiconductors, and then those semiconductors go to a customer and they use them in something else that helps the sustainability market.
Exactly.
Okay, great. So as we focus on the sustainability market, again, very broad, how do we break that up? What are the major categories?
So there's four main categories. The first one is just generating cleaner energy.
Okay.
And so that could be wind or solar energy. Oftentimes there's energy storage associated with that.
Okay.
So you have solar panels that take sun from the sky, and you're converting that energy, but it's only available to you certain times a day. So you need to store that somewhere. So energy storage is a big piece. And then the grid as well can be a piece of that category.
Okay. So in that market, obviously a lot of different application areas, and there's different levels of technology in there. So if we think about solar panels, for example, there are stationary solar panels, but then there are also panels that move and track the sun, and there are even steam generating solar systems versus the panels, right? So there's a lot of different technology that goes into each one of those.
For sure. The PV panels or the solar panels themselves oftentimes have technology built in to help optimize their output. And so as the cloud conditions and sun conditions change, they can actually rotate and change to optimize for maximum energy output.
Okay, so let's talk about resource monitoring and optimization. What are the main applications in that space?
So within that category, a lot of it is about making smarter decisions with the information we have. So smart meters, smarter building automation, and things as simple as leak detection or turning the lights off when somebody's not in the room.
Okay, so I'm thinking about things like just a very brute force is when I'm at home and I've got a magnet on my fridge that tells me when energy is cheaper to use, and that's when I should run my washing machine. But this technology actually automates that into a home or building, correct?
It can. Sometimes it's as simple as a display that you have in your house that tells you what energy is being consumed, something that can help with what the energy rates are. But in other times it's fully automated and can turn the lights off or temperature up or things like that when nobody's around.
Right. So again, if we think about our individual residents, time of use is a very small change, but if we think about a large-scale office or factory that scales up and can create significant savings, excuse me, for the operator.
For sure.
Okay, let's talk about efficient energy and water use. What's going on in that space?
So efficiency is really important because we're not all going to just stop using energy. You know, all the things that we do for convenience in our daily lives, we're going to keep consuming energy. But if we can make all the things that we interact with a little bit more efficient, then that impact together can be significant.
Right.
So think about as we're converting power, as we're controlling motors, all of those things, if we can do them more efficiently, is very important. And also things like the appliances, the things that we use on a day-to-day basis, making sure those are Energy Star compliant.
Sure.
Those all kind of fall within that energy and water efficiency category.
Let's talk a little bit more about motors, because that's a big one, right? A lot of energy globally consumed just by motor use. So there are really basic motor controls, and there are really advanced motor controls that are intended to maximize efficiency. Can you give us an overview of that landscape?
Sure. So within motor control, I kind of view it as three main steps that you can use to increase motor control efficiency in an end design. The first is the selection of what type of motor. So adopting newer motor types like BLDC motors or PMSM motors, those just by nature of the hardware itself are much more energy efficient.
Okay.
And then the second stage is operating with variable speed. And so if you have a motor without variable speed, oftentimes you're doing more than what's actually needed. With the variable speed, you can adjust and do just the amount that's needed of the control at a given time for torque or speed. And then with the third piece, it's really the advanced algorithms. So we have different controllers in the portfolio that can do more precision control with algorithms like field-oriented control and things like that.
Okay. Now, again, with motor control, how important are algorithms and tools in configuring the hardware and driving everything to maximum efficiency?
Very important for multiple reasons. One, it helps get the designs done faster, and two, it is a complex design. And so Microchip has tools like Motor Bench that can help with configuring the motor parameters and customizing the algorithms for a given application.
Okay. Thanks. So let's talk about that last category, reuse and waste reduction.
So this one's important as well. Many of these applications aren't brand new. A lot of these are things that have been around for a while, but making sure that we are able to recycle and reuse things. One good example in this category is like the irrigation system that we have at home. When we can add the smarts in there so that we don't water the lawn when it's just rained.
Okay,
Those kind of applications are good. Other examples in this category are things like asset tracking. So if you always keep track of where a thing is, you don't need to replace it as often.
Okay.
Other examples would be like the water in public restrooms. So when you go to wash your hands, the water doesn't stay on forever. If somebody forgets to turn it off, that's going to turn off. So a lot of those types of automations that are part of our daily lives that have an environmental impact.
Okay, great. So a huge disparity in the size and the power consumption, lots of different applications here. Are there still common challenges from a design perspective that somebody needs to think about when they are implementing one of these types of systems?
There are some common design challenges that we see across that broad array of end applications. The first one is in just generating cleaner energy. And so this is a product category with a lot of innovation and a lot of new design activity happening. There's big challenges in how do we make sure we keep the sources and make sure that as we're generating from wind or solar or things like that we make sure we don't have tons of losses as we go from one stage to the other in the grid.
Okay. And then that power needs to be converted and moved around?
It does. So there's always some type of power that's being converted no matter what that original source was. And each time we convert it from one level to another, we want to make sure that the losses are minimized. There's some algorithms called maximum power transfer or MPPT type of algorithms that can be implemented. And the other piece of power conversion is making sure some applications go to sleep when they're not being used, so they actually just conserve more power when they're not needed.
Sure, and that seems like an area where there would be a lot of benefit from added intelligence. So just like detecting faults or errors, monitoring to see what the real world conditions are, and adapting these networks on the fly.
Exactly, having more information on when you actually need to use that energy instead of having it on all the time.
Okay, let's go back to motors again. So lots of these applications need motors. We talked about algorithms and tools and software. What's the benefit to the network of just more efficient motors?
So I think the biggest advantage, I guess if we back up, motors consume over half of the energy globally.
Okay.
And so, if you think about the number of motors you interact with on a daily basis, there's probably 40 or 50 in your car, there's probably 100 in your house, the elevator on your way to work, that just motors are hidden in many different places. And so if you can increase the efficiency in all of those motors just by a little bit, the global impact can be significant.
Okay, awesome. All right, and last area I guess was smarter decisions, and this we talked about that with converting the energy and the electricity, but this really pervades all of these sustainability applications.
It does, and sometimes in IoT they'll call it edge computing,
Sure.
but really it's whatever thing you can do that's closest to where the information is sensed. You can make decisions that turn things on or off, and that impact can save energy.
Okay.
So I think you guys will talk next week about smart agriculture.
We will.
But there's a really good example there of applying pesticides.
Yep.
We don't want tons of pesticides on our food, but we want to make sure that the crops are efficient.
Yep.
And so applying pesticide just where it's needed on a very minimal basis is an example of making smarter decisions that have a big environmental impact.
Right. Okay. So there are some common design challenges, and there are going to be some main technology categories that people use to address these challenges. So let's talk through those if we could. So first, just the intelligence. All of these require processing power and decision making. Can you tell us a little bit about the main technologies that can be deployed there?
Sure. Microchips well known for our microcontroller portfolio, and this is an application space where that really shines. So whether it's the simple applications like leak detection or sensing if there's motion or things like that, we've got the low power 8-bit microcontrollers in that space. All the way ranging up to the FPGAs that can do pure embedded vision, and so everything in between can be some of that controller space, including specialized products that do intelligent power conversion and efficient motor control.
Right. So again, that's as you said, that's a pretty broad spectrum. So there's everything from small, simple peripherals to embedded cores and embedded application solutions. Here again, how important are the tools and the software and the algorithms?
They're very important. It helps jumpstart the design, and our goal is really to get people to that kind of 70 to 80% of the way there, as simple as possible, and then they can add that last 20% of really how to differentiate their end products.
Okay. Communication's a big piece. All of these, everything in the world is becoming more connected. So what are kind of the main decision criteria, or what are the things that people need to think about when thinking about their communication networks?
Yeah, there's a lot of different options for connectivity, and I think the first decision is, does wired or wireless make the most sense in a given application? So in the smart farm example that we were talking about, or even in other large factories, wireless is going to make more sense because they're just more spread out. You don't want to have wires that communicate that information back. Where in other applications, having a more robust wired connectivity like USB or Ethernet might make more sense.
Okay. All of these things need to be secure. The processing capability, the communications network, they all need to be secure. So what are the things that somebody should think about, particularly with sustainability and security?
So as more things are connected, the importance for security becomes higher and higher. My rule of thumb is if you've got any kind of connectivity in your application that's beyond just your system, it's really important to add in security. And then it's a matter of how much security do you need. There was one example or story of a fish tank thermostat that somebody used to hack into a casino.
Yep.
And so it's not that that fish tank thermostat mattered that much, but it gave them access to a network that had very sensitive information on it.
So it's not the fish tank, it's what the fish tank is connected to.
Exactly.
Okay. Who would have thought?
Yeah.
So, all right. So, again, all of these things need power. So there's a range of power supply solutions, all dependent upon efficiency and what your power levels are.
So in addition to the controller, the connectivity, all the inputs around it, having the right power management is important. So with those breadth of application spaces, some are fairly low voltage. We've got LDOs and voltage regulators, all the way up to very high voltage silicon carbide.
Okay, and I guess just the last thing to think about in terms of that solution would be signal chain stuff. So this includes sensing things and getting that information into the processing and across the communication lines.
Yeah, last thing to think about on this slide, but really it's the first thing in the equation, right?
Okay.
You start with what you're sensing, and,
Yep.
and then you can control it, and then you can connect it. So
Yep.
in many ways, it's the most important piece of the equation: temperature sensors, humidity sensors, and
Yeah.
so forth.
Yeah. Okay. So we talked a little bit about, well, we've talked a couple of times about algorithms and software and tools. We've talked a little bit about the breadth of technologies that people need to deploy. So how do we help people bring all of these things together?
So we've got the silicon pieces that people can use. We talked about the design ecosystem and the development tools. And then one other piece that we're trying to do to bring things together is in full reference designs.
Okay.
And so if you go to microchip.com/reference designs, you'll see a list of all the reference designs that are available across many different markets. And if you're interested in the sustainability space, you can filter down there for sustainability and see reference designs ranging from refrigerator compressors, HVAC or heat pumps,
Right.
things like solar microinverters. Or even we've got an 11 kilowatt totem pole PFC reference design that can be used for kind of bidirectional inverters in string inverters.
Okay. All right. Thanks so much. I think at this point we'll move to a little bit of a Q&A session.
Okay.
Again, thanks for sharing all that. It's a fascinating area. So to our viewers, if you haven't asked a question, you can post a question in the social media. I'm going to start off with what we call the FAQ. So I am going to go to my cheat sheet here.
Okay.
But these are the frequently asked questions that we have about this topic. So first, in terms of how we define it, how is the sustainability market different or related to the e-mobility market?
So that's a really great question. So there's a lot of crossover between the two, and they're very synergistic. I don't know if you've ever done any home renovation projects, but in my experience, you start with one room,
Yep.
and then all of a sudden you got to do the next room and the next room. It kind of is a slippery slope.
Very.
And so that's my analogy for you go out and you invest and you buy an electric vehicle. So the next step, you need the charger in your garage. And then you've got this infrastructure and you think, well, maybe I should add the battery so that I've got a good backup battery, because that interfaces with the charging facility. And then all of a sudden you need solar panels on the roof of your house. So there's quite a bit of synergy even at a residence. Now scale that up to a factory.
Yep.
People are putting solar panels on the rooftops, and that can help defer some of the costs for their HVAC systems. Having those energy storage at a factory can be helpful for backups if energy sources ever go down.
Sure.
And then you can also have the solar panels that help fuel the EV chargers for your employees.
Sure.
So it's kind of a fully intertwined ecosystem.
Okay. Interesting. Very interesting. All right. Second one. How's the purchasing behavior of consumers changed with respect to sustainability initiatives?
Drastically. So I think there have always been people that cared about the environment and cared about sustainability. There have been movements throughout the decades. But I think that the change is now consumers are willing to sometimes spend more or be very differentiated in what brands they're willing to invest in based on that company's supply chain and based on their sustainability goals.
Okay.
And so it can be a decision and sometimes a primary factor in a purchasing decision. Where I would say 5-10 years ago, it might have been a nice to have, but it
Right.
wasn't usually a factor in deciding.
Interesting. So continually evolving. All right. Next question: is global energy consumption still increasing, and what's driving the increase?
It sure is. I think that the last stat I saw was over the last 20 years, we've doubled our energy consumption, and it's not slowing down anytime soon. If you think about how much more we store in the cloud today than we did 5-10 years ago,
Sure.
all that has to be stored somewhere.
Sure.
So the data centers are growing.
Yep.
And then we're just on the cusp of all of the AI and ML initiatives that will drastically increase the need for more computing and more storage. So our energy use isn't going down anytime soon.
We're not storing our pictures and photo albums anymore. We're storing them on the cloud, and
Exactly.
we're storing this video on the cloud.
Yes,
Okay, interesting. All right, two more. How could a small increase in individual motor efficiency have a significant impact?
So we talked a little bit about the number of motors, and if you think about, I think there's hundreds of billions of motors that are operating right now as we talk. And so if each one of those increased their efficiency by 1, 2, 5%, I think the answer is a significant global impact that could save up to 10% of global energy use.
Yeah.
And you look at, recycling, you look at, all the other things we could do.
Yep.
That's a pretty significant impact compared to other initiatives.
A couple watts in every motor adds up to terawatts very quickly.
You got it.
All right, last one. Let's talk specifically about reference designs. What reference designs do we have available, and are there any new ones coming out imminently?
So the most popular reference designs we have around sustainability are the solar microinverter. Gets a lot of interest. We also have things related on the e-mobility side that kind of fall into the sustainability area as well, like our two-wheeler and e-bike type reference designs. And then in the area of appliances, the refrigerator compressor shows high efficiency motor control, as well as we've got an HVAC or heat pump type reference design that can show energy efficiency in those type of applications.
Okay. Excellent. Alexis, thank you again for joining us and sharing your expertise on this.
Thanks,
Thank
Eric.
you to our audience for joining us today. If you like this episode, please click that like button. If you think it'll be useful to a colleague, please share it. And please subscribe to the channel if you think this series will be useful to you. Please visit us at microchip.com/designs for the edge. There you can see the rest of our series. We'll be broadcasting every week, starting this week for 6 weeks. Next week, we will be talking about smart agriculture and smart farming, as you mentioned earlier. Thank you again, and see you next time.